A clustered B+3 file is a file that includes actual data records ordered based on a B+3 index. We are going to use some assumptions borrowed from results of empirical studies for the case of clustered files. Studies show that in a clustered file, pages are usually at about 67% occupancy. So, if the number of pages with packed records is B, we can assume that we have 1.5 times B pages with 67% occupancy for the same number of records. This will simply add the 1.5 coefficient to the scanning cost, which includes scanning all of the records in increased number of pages due to lower occupancy. In tree-based indexing, records are organized in a tree-like structure in a sorted order by search key value. Using the tree structure, searches are hierarchically directed to the leaves, pointing to the correct pages of data entries. Starting from the root and going towards the leaves, traversing the length of the tree is required, which depends on the fan-out F, which is number of children in non-leaf nodes. Locating the first page, therefore, will take logarithm of 1.5b to the base f. Therefore, d times this value provides the I/O cost. Once the desired page is fetched, finding the record within the page could be performed using binary search again, and therefore logarithm of r in base 2 steps, each with cost c. If there are multiple records with the same value on the search key, they will be adjacent to each other due to the sort. This will only affect the cost by sequential reading of adjacent multiple records. Search with range selection will also include the same search for equality selection, followed by fetching the pages as long as they are within the match range. In a clustered B+3 file, we need to find the correct leaf page to insert a new record. This is similar to the cost of search. Then we must add the new record. Remember we said that the pages are on average on 67% occupancy. So usually there should be enough space to add the new record without any additional work. Occasionally, if the leaf page is full, there is a need to fetch and modify other pages. But we ignore that here and assume the case that the page has enough space. In this case, the cost of insert would be cost of search plus updating the page, which is D. Delete works similar to insert, with finding the page and applying the right of the page with the target record removed.